Okay, so today we'll be looking at dividing polynomials, and we're going to do this using the area model. So if you are curious as to what it's called, there's multiple ways to do this, but we're going to do it using the area model, which is how we've been multiplying a lot of polynomials also. So I'm going to go ahead and set up our box that we're used to using. And the only side of my box that I know at this point is the n plus 2. And then I know that everything inside my box is going to be this first polynomial that I've given, that n to the third. So we always start by putting this first polynomial, or this first term of our polynomial that we see, inside this first box. So n to the third. Now I'm going to ask myself, what do I multiply n by to get to n to the third? And that's n squared. Now to keep with the pattern of multiplication, I have to do n to the second power times 2, which gives me 2n squared. Now I don't have a 2n squared in my problem, I have a 5n squared. So I know that whatever is in this 2n squared plus whatever is in this box have to give me 5n squared. So 2 plus 3 is 5, and it would be 3n squared. So I do the whole process again. So what do I multiply n by to get to 3n squared? But that would be 3n. Then I do the same thing. So 3n times 2 is 6n. And I know that I need 6n and something else to be negative 3n. And that something else is negative 9n. So what do I multiply n by to get to negative 9n? But negative 9. And then negative 9 times 2 is negative 18. And I needed that last box to be negative 18 from my problem. So my answer is just what's on the top. N squared plus 3n minus 9. Perfect. And I know that can feel a little funky, so we are going to try it again on number 2. So again, in number 2, I'm going to set up my box. I know that I'm going to have a k plus 5 on the outside, but I'm going to need to do some investigative work to find out what's on the inside. So my first term goes in the first box, so k to the third. What do I multiply k to the third by, or k to get to k to the third by? But k squared. So k squared times 5 would be 5k squared. But I don't need 5k squared. I know from my original problem that I need both of these to be 4k squared. So to get from 5 to 4, I have to subtract 1. So this would be a minus 1k squared. And k times negative 1k would give me k squared. So negative 1k times 5 would be negative 5k. But I don't want it to be negative 5k. I need a negative 3k like it says in my problem. So to get from negative 3 or negative 5 to negative 3, I would have to add 2k. So k times a positive 2 gets me to 2k. So 2k times, or 2 times 5 would give me plus 10. But I don't need just 10. I actually need 15 in the last box. So I'm going to have a plus 5 outside. So when we write our final answer, I have to include what's on the top. So k squared minus 1k plus 2. But then my remainder is actually 5 over k plus 5 because it's not inside my box. So whenever there's a remainder, we can write it like that. All right, let's look at another one. So again, I'm going to set up my box. It's kind of a bad box. Let's redo that. And put in what I know, which is x minus 4. And I know that the first box has to be the very first term. So that would be 9x to the third. So what can I multiply x by to get to 9x to the third? That's 9x squared. So 9 times -4 is going to give me -36x squared. But I don't need -36. I know from my problem that I need a -44x squared. So to get from -36 to -44, I need to subtract 8x squared. So what do I multiply x by to get to -8x squared? But -8x. And then I do the whole process again. So -8 times -4 would be +32x. But I don't need 32x. I actually need 29x. So to get from 32 to 29, I need to subtract 3x. So what do I multiply x by to get to -3x? Would be -3. And then -3 times -4 would be 12. I don't need 12. I need 4. So I'm going to have to subtract 8 on the outside. So now I write my final answer, 9x squared minus 8x minus 3, and then 8 over x minus